Watch the complete playlist on the app Pions. Download the app now.
Great. Let's start with our new chapter, electric potential and capacitance. Question number 1. It says calculate the potential at any point P due to charge of 40 microcoulomb located 90 centimeter away from the charge, right? So to find the potential, the formula for potential here is V equals to K Q by R. Let me remind you once again, K is nothing but 1 by 4 pi epsilon naught Q by R, where Q is the charge and R is the location at which we are finding the potential. Potential is a scalar quantity. Let's substitute here values. 9 into 10 to the power 9. Charge is 40 microcoulomb. In case if you don't know micro, let me remind again. 40 into 10 to the power minus 6 divided by R. 9 centimeter it is. So be very careful. You have to convert it into meters to get it in standard units. Clear? Let's simplify. 9 cancels with 9 and 40 as it is. 10 to the power 9 and 10 to the power minus 6, 10 to the power 3. So let me just write it as 10 to the power 3 for the time being. And let's take this 10 to the power minus 2 up. So it will be 10 to the power 2. So it will be 4 into 10 to the power 3, 2, 5 and 1, 6, 10 to the power 6. 4 into 10 to the power 6, 4 megavolt or million volt. You can write it if you want to, or you can leave it as 4 into 10 to the power 6 volt. Both are fine. Be very careful. Mega or million is capital M, not small m. So this is our question number 1. Let's move to question number 2. Question number 2 says a metal wire is bent in circle of radius 10 centimeter. So there is a wire over here and the radius of this wire is 10 centimeter. Okay, this wire is, so let me write here in small r equal to 10 into 10 to the power minus 2, so that later I don't forget it to convert it into meters. It is given a charge q is nothing but 200 microcoulomb. Micro is 10 to the power minus 6 coulomb. So charge distributed all over this ring is 200 microcoulomb. It spreads on it uniformly. Uniformly means it's not varying. It's uniform all over. Calculate the potential at its center. To find the potential, again, it will be 1 by 4 pi epsilon naught q by r. So what is our 1 by 4 pi epsilon naught? 9 into 10 to the power 9. Now I hope all of you got used to this. Charge is 200 into 10 to the power minus 6 whole divided by r, which is 10 into 10 to the power minus 2. Great. Let's cancel out this with this. We left with 9 to the 18. So 180 into 10 to the power 9 minus 6, 3. And let's take this 10 to the power minus 2 on the top. It will be plus 2. This will give you 180 into 10 to the power 5. Or you can say 1018 into 10 to the power 6. What's the unit? Volts. That's your answer to question number 2. Let's move to question number 3. Question 3 says electric field intensity at any point B due to a charge capital Q kept at a point A is 24 Newton per Coulomb. Let's understand and try to draw a rough diagram. This is our A, this is our B. Okay, one second, what happened? So this is our B. Okay, so electric field intensity at point B due to a charge kept at A at this point. What's the separation? We don't know yet. Later we will add it. So electric field at B due to A is 24 Newton per Coulomb, standard units. Fine. Charge is Q. And the electric potential at point B. So potential here is how much? Due to the same charge, 12 joules per Coulomb. Fine. This is our potential. Sir, joules per Coulomb, you were saying volt. Both are same. Don't get confused. Voltage has two units, either volt or joules per Coulomb. You call it as potential difference or you can call it as voltage also. That is also fine. Next question say, next part says calculate the distance AB and also the magnitude of charge. So let me remind you the two relations. In the first chapter we learned electric field is nothing but 1 by 4 pi epsilon naught charge Q upon R square. And potential V we have learned it is 1 by 4 pi epsilon naught charge Q by R. If we divide E by V, let's see what we get. So dividing electric field E upon V, we get how much? We get our Q cancel, 1 by 4 pi epsilon naught cancel, and 1 by R. Clear it is? So if you cross multiply, voltage V is equals to electric field into R. You can do that. Or if you want to calculate R, simply R is V by E. R is V by E. So let me remove these formulas, okay, uh, for the timing, or let me keep it like this only. R will be equals to V by E. So what is the voltage? 12. And what's the electric field? 24. 12 by 24, 1 by 2, which is 0.5 meters. Yes, because we are using standard units. Now you got your R. The separation R is AB. In case if you are not clear, AB is R. If AB is 0.5, can we find the charge? Yes. So what will be the charge? From this equation I am solving, so that to avoid this square term and all. So Q is nothing but V into 4 pi epsilon naught into R. Now what's the voltage? Sir, voltage here is 12 joules per coulomb. 4 pi epsilon naught. Sir, if 1 by 4 pi epsilon naught is 9 into 10 to the power 9, then 4 pi epsilon naught is 1 upon 9 into 10 to the power 9. As simple as that. Let me repeat this term again. If 1 upon 4 pi epsilon naught, that is k, is 9 into 10 to the power 9, then the reciprocal of that is 4 pi epsilon naught. So it must be reciprocal of the value. R is 0.5. Clear? So this will give you here 12 into 12 is a 60. So 6 by 9 into 10 to the power minus 9. Okay, I multiply 12 with 0.5. It gives me 6. Now 3 twos are and 3 threes are. So 2 by 3 into 10 to the power minus 9. And what's the unit of charge? Coulombs. Do write the units. Otherwise, they will cut your marks. This is our question number 3. Clear? Let's move to question number 4. Question 4 says, a charge 24 microcoulomb is given to a hollow metallic sphere. Hollow metallic sphere. This is our metallic sphere. And here the charge, this is metallic sphere with any radius. Okay, radius here is given 0.2. So let me write here R will be equals to 0.2 meters. And charge Q given to the sphere is 24 microcoulomb. Let me write it as 10 to the power minus 6 coulombs. Okay, so charge is all over distributed to this metallic sphere. Find the potential at the surface of the sphere. So potential at the surface of the sphere is V, that will be equals to 1 by 4 pi epsilon naught, that is K, Q by R. Very simple, direct question. So that is 9 into 10 to the power 9. Charge is how much? 24 into 10 to the power minus 6 whole divided by the radius, which is 0.2. Let's simplify. Let's remove this point. You will get an extra 10 here. Let's cancel out this with 12. So you got here this. So 12 into 9, 108. Let's simplify the powers. 9 minus 6, 3. 3 and 1, 4. 10 to the power 4 volt. Now this is the voltage at on the surface of the sphere. Now the question is at a distance of 0.1 centimeter from the center of the sphere. Now listen very carefully. Okay. Because of this second part, I have placed this particular previous year board question. Only because of the second part, because majority of people go wrong here. At a distance of 0.1 centimeter from the center of sphere. Now what is the radius of the sphere? 0.2 centimeter or 0.2 meters, sorry, as per the question. So if it is 0.2 meters, okay, then the question is where will be 0.1 centimeter? So if this is 0.2 meters, then centimeter will be somewhere here, correct? So if that is somewhere there, is it inside the sphere or outside the sphere? Sir, it is inside the sphere. If it is inside the sphere, listen very, very carefully. And if it is a metallic sphere, it is a good conductor. So always remember, for a good conductor, potential is always constant throughout the volume of the conductor. Let me repeat again. For a conductor, the potential is always constant throughout the conductor, inside the conductor, not outside. So if this length was greater than 0.2 meters, then you would use the formula again 1 by 4 pi epsilon naught Q by R. As the R increases, the potential decreases. But since this point is lying inside the conductor, the property of conductors, very, very important. The potential throughout the volume of the conductor remains same. So answer for question number 4, second part is 108 into 10 to the power 4 volt. Where people go wrong, they substitute R as 0.1 and try to figure out the new value of voltage. So be very careful with this particular part. Here they have used a concept. So concept is potential is constant. Done. Let's move to the next one. Question number 5. Question 5 says 2-point charges. First charge is here, which is 3 into 10 to the power minus 8 coulomb. And the second charge, let's say it's here, minus 2 into 10 to the power minus 8 coulomb. Both are separated at a distance, are located at 15 centimeter apart. So separation between both the charges is 15 centimeter. This is A, this is B. Point A and point B where the two charges are placed. At what point on the line joining the two charges is electric potential 0? Let's say it is 0 at point P. Let me repeat. Let's say at any point P, the potential is 0. What is the distance of AP? It's X. I have assumed. So what will be PB? 15 minus X. Be very careful. So I assumed that at any point P, the potential is 0. Now, sir, what is the superposition principle? Superposition principle says the net potential at any point P must be equal to potential due to the first charge due to the potential due to the second charge. So VAP is potential due to A at point P plus the potential at P due to the second charge B. Great. Okay, now what is VP? As per the question, the potential at point P must be 0. Net potential here is 0, so let's put here 0. Now what is VAP? VAP is 1 by 4 pi epsilon naught, the first charge, which is 3 into 10 to the power minus 8 upon the separation X. I hope this is clear. Plus 1 by 4 pi epsilon naught, the second charge. Be very careful, I am taking the negative sign. Now 90% people are confused. Sir, why you are taking negative sign? Last lectures in first chapter, you were saying no negative sign is considered. Listen very carefully. Potential and potential energy both are scalar quantities. So magnitude of charge is taken. In case of force and electric field, they are vector quantities. This negative sign is considered in directions. So here the negative sign will be considered. So be very careful with this. Let's take this negative sign on the left hand side. So it becomes positive 2 into 10 to the power minus 8 whole divided by 15 minus x, and in front there is 1 by 4 pi epsilon naught. And this is equals to 1 by 4 pi epsilon naught 3 into 10 to the power minus 8 whole divided by x. Let's cancel out 1 by 4 pi epsilon naught with 1 by 4 pi epsilon naught. Let's cancel 10 to the power minus 8 with 10 to the power minus 8. 2 upon 15 minus x will be equal to 3 upon x. Now, if we cross multiply this, we will be left with, let's go to the next page, 2x is equals to 3 times 15 minus x when you cross multiply them. So this will give us 2x is equals to 45 minus 3x. 3x taking on the other side, 5x, 2x plus 3x is 5x equal to 45. And x is equals to 9 centimeter because I didn't convert, I took x as centimeters only. To avoid that confusion, sir, what if I by any chance I convert it in meters? Then you have to use here x into 10 to the power minus 2. Here also x into 10 raised to minus 15 minus x into 10 raised to minus 2. And here you will get an extra factor of 10 raised to minus 2 that will cancel out eventually. Okay, let me repeat again. If you are taking meters, it will be 10 to the power minus 2 here also, and here also 10 to the power minus 2, and that also cancels out, so don't worry about that thing. But here we are finding in x in terms of centimeter because the separation is in centimeters. So final answer should be in centimeters. So our answer for this question is 9 centimeter. From whom? From the charge A. Great. Let's move to our Next question. Question says, calculate the electric potential at the center of a square. So let's draw here a square. So our square here is this, let's say. Each side is root 2 meter. So let's write here root 2 meter. This is our A, this is our B, this is here C, this is here D. Having charges, let's go in the same order. 100 microcoulomb. So I'm for the time being, I'm just, okay, let me write only 100 microcoulomb minus 50 microcoulomb, 20 microcoulombs, and is minus 60 microcoulombs. They are placed at ABCD at the four corners. You have to find the potential at the center of the square. Let me remind you again, scalar quantity it is potential. So if it is at O, first thing, we have to find potential at O due to A. So you need the separation OA, OB, OC, and OD. Correct? To find OA, OB, OC, OD, let's start with our basic geometry because it's a square and each side is of root 2 meter. Let's take here, this is our root 2 meter here also. So let's take the triangle BCD. Using Pythagoras theorem, BD square is equals to BC square plus CD square. Now BC is nothing but root 2, so root 2 square, and CD itself is also root 2, so root 2 square. Root 2, here it will give you 2 and here also 2. So this will give you 4. Now BD square is 4, then root will be, BD will be complete 2, 2 meters. Now if BD is 2 meter, it is a square. So for a square, the diagonals must be equal. AC will also be 2 meter. Great. If BD is 2 meter, AC is 2 meter, let's figure out our values of AO. That will be equal to OB, equal to OC, equals to OD. Sir, why they are equal? Square, the diagonals of a square bisect each other. Bisect means they cut in equal parts. And each will be equal to 1 meter. Again repeating, if this gap here is 2 meters, then half of this gap will be 1 meter. So we got the values. Now let me write here the formulas which I will use to figure out the potentials. So potential at O due to A, that will be equals to 1 by 4 pi epsilon naught charge at A upon OA. Very simple. Potential at O due to B, 1 by 4 pi epsilon naught charge at B upon OB. VOC, 1 by 4 pi epsilon naught charge at C upon OC. Finally, charge potential at O due to D will be 1 by 4 pi epsilon naught charge at D upon OD or DO, whatever you want to write. Clear? Great. What should be the net potential? Let's write it on another page. So net potential at O, the center, must be equal to voltage due to O at O due to A, due to B, due to C, due to D. Sir, why you are directly adding them? First thing, again repeating, it's a scalar quantity. We don't find directions for scalar quantity. Scalar quantity doesn't have directions. Second thing, this law is known as superposition principle. According to superposition principle, the net voltage at any point is equal to the sum of individual voltages due to the charges at that point. Clear? So let me remind you once again, all of them, let's write here 1 by 4 pi epsilon naught charge at A upon OA, 1 by 4 pi epsilon naught charge at B OB, 1 by 4 pi epsilon naught QC OC, 1 by 4 pi epsilon naught QD OD. Let's take common things. Pay attention. OA, OB, OC, OD all are equal. Just now we found they are 1 meter. So let's make it as OA, OA, OA. They are all same. So you can write anything. If you are not comfortable with OA, write it OB or OC or OD, doesn't matter. Now what is common here? 1 by 4 pi epsilon naught into OA is common. Let's write it as 1 by OA. What we left with? Charge at A plus charge at B plus charge at C plus charge at D. Correct. Now what is 1 by 4 pi epsilon naught? We already know 9 into 10 to the power 9. What's the value of OA? 1. Charge at A, let's see the question once again. Charge at A is 100, minus 50, 20 and minus 60. So let's go back. 100 minus 50 plus 20 minus 60. Let me repeat again. These are our negative. 100 minus 50, 20 and minus 60. What about, sir, microcoulombs? So let's, all of them have microcoulomb. So let's take that common also and keep it outside 10 to the power minus 6. Let me repeat. Anyways, you will write it as 100 into 10 to the power minus 6, 50 into 10 to the power minus 6, 20 into 10 to the power minus 6, and 60 into 10 to the power minus 6. You can take 10 to the power minus 6 common out and it will go there. But be very careful. Signs for potential and potential energy is very, very important. So let's multiply. 1 by 1 is anyways 1. 10 to the power 9 and that 10 to the power minus 6 outside. That will make it as 9 into 10 to the power 3. And here 100 minus 50. So 50. 50 plus 20. So 70. 70 minus 60. So 10. So our net voltage at the center of the square is 10 to the power 4 volt. 9 into 10 to the power 4 volt. This was our question number 6. Let's move to question number 7. Question number 7 says two positive point charges 0.2 microcoulomb. Let me write here 0. Okay, 0.2 microcoulomb and 0.01 microcoulomb. They are placed at 10 centimeter apart. So the gap is 10 centimeter. Clear? Calculate the work done in reducing the distance to 5 centimeter. Okay. Now 90% people will do what? They'll straight away write K Q1 Q2 by R and R as 5 centimeter. That's not correct. Let me repeat again. Let me first write the formula for work done. In case if you are not familiar, I have already explained work done is potential energy. Potential energy is the work done. So that will be 1 by 4 pi epsilon naught Q1 Q2 by R. And as the majority people go wrong here is they directly take R as 5 and solve and that's the answer. No. When you already have them at the position of 10 centimeter, there was some potential energy. And what is that potential energy? Let's first find that. So initial potential energy is UI, let's call it as 1 by 4 pi epsilon naught, 9 into 10 to the power 9. Charge is Q1, Q2 is, Q1 is 0.2 microcoulombs, 10 to the power, how much? Minus 6. Q2, 0.01 into 10 to the power minus 6 whole divided by 10 centimeters. So 10 into 10 to the power minus 2. This is initial potential energy when they were already at 10 centimeter. This was the work you were doing when to keep these charges at that place. Now, when you are shifting it, new energy required will be, okay, so calculate the work done in reducing the distance. So to reduce, okay, to get the potential and you have to subtract both. So 9 into 10 to the power 9, 0.2 into 10 to the power minus 6, 0.01 into 10 to the power minus 6 whole divided by 5 into 10 to the power minus 2. So how much work you have to do? It's already this much you are doing. And here you have to get it. So you have to subtract it. So the total energy will be, energy required will be, or work done will be equals to U final minus U initial, right? So when you subtract it, let's write all the parameters again and then I'll solve it. 9 into 10 to the power 9, 0.2 into 10 to the power minus 6, 0.01 into 10 to the power minus 6 whole divided by 5 into 10 to the power minus 2. Subtracting here 9 into 10 to the power 9, 0.2 into 10 to the power minus 6, 0.01 into 10 to the power minus 6, whole divided by separation, which is 10 centimeter, 10 into 10 to the power minus 2. Now you can see that numerators are common, so let's take them common out. 9 into 10 to the power 9, 0.2 into 10 to the power minus 6, 0.01 into 10 to the power minus 6, and here you left with an even 10 to the power minus 2 in the denominator is common. Here you left with 1 by 5 minus 1 by 10. Okay, now let's simplify. So first of all, let me remove this point and make it 10 here. Let me remove this and make it 100 here to make it simple. Okay, so 9 2s are 18, so magnitude is clear, 18 into 10 to the power 9 and minus 6. 9 minus 6, 3. 3 minus 6. 3 minus 6 is minus 3. 10 to the power minus 2 into 100. That is 10 to the power 2. So that will cancel out. 10 will be left, which will go up and make it 10 to the power minus 1. Let me repeat again. 10 to the power minus 2 and 100. 10 to the power 100 is 10 to the power 2. So that will cancel out. 10, this which you left with, you can take it up. It will be 10 to the power minus 1. 10 minus 5 upon 50. I hope this is clear. So this will give here 18 into 10 to the power minus 4 into 5 by 50. 5 tens, 10 goes up. This will give you 18 into 10 to the power minus 5 joules. Done. This is the extra work you have to do on this system of charges to get it at the position of 5 centimeter. Let's move to our next question. Question number 8, it says an electric dipole of length 2 centimeter. So 2a, which is the dipole length, which is itself is 2 centimeter, 2 into 10 to the power minus 2 meters, because centimeter can be our standard unit, says meter, is placed with its axis of the dipole, making an angle theta of 60 degree to a uniform electric field E, which is equals to 10 to the power 5 Newton per Coulomb. Fine. If it experiences a torque tau is 8 root 3 Newton per meter. Newton meter, it is not Newton meter. Torque unit is Newton meter, yeah. Calculate the magnitude of the charge on the dipole and the potential energy. So let's recall from our first chapter. Torque tau is equals to PE sine theta, where theta is the angle between the dipole and the electric field. Now P, dipole moment, was nothing but 2aq into electric field E into sine theta. Now what 2a is given? Yes. E is given? Yes. Tau is given? Yes. And theta is given. What is not known here? Q. So Q will be equals to torque tau upon 2a E sine theta. Now what is torque? So torque here is 8 root 3. 2a is 2 into 10 to the power minus 2. Electric field 10 to the power 5 sine 60 degree. If you are a bio student, you should remember all the values till at least pi, 180 degree, 30, 45, 60, 90, 120 and so on. So sine 60 is root 3 by 2 in case if you don't know. Let's substitute here root 3 by 2. So root 3 and 2 will go on the top. Root 3 cancels with root 3, 2 cancels with this 2. 8 into 5 minus 2. So 5 minus 2 is 3. And 3 goes on the top. 10 to the power minus 3 coulombs. This is our charge. Done with the first one. Second one, they are saying find the potential energy. So one second, potential energy, let's do it here. So potential energy is U, which is minus PE cos theta. PE cos theta. So this will be minus 2AQ electric field into cos of angle theta. What is 2A? 2A is 2 into 10 to the power minus 2. Charge, just now we found 8 into 10 to the power minus 3. Electric field, 10 to the power 5, and cos 60. So what is cos 60? Sir, cos 60 is nothing but half. So let's substitute here into 1 by 2. Let's cancel this 2 with 2. So we left with here minus 8 into 5 minus 3 is 2 and 2 cancels out. So you left with 8 joules. That's your potential energy of a dipole. Be very careful. The formula for torque is Pe sine theta. Potential energy is minus Pe cos theta. Okay, such a difference, small difference. Great. Let's move to question number 9. A capacitor of unknown capacitance is connected across a battery of V volt. Let's draw a rough diagram. A capacitor C, let's call it. We don't know what's the value of C. And it is connected to a battery of voltage V. Great. The charge stored in it is 360 microcoulomb. So Q is 360 microcoulomb, 10 to the power minus 6 coulombs. Great. Which is the charge stored in this capacitance. When the potential across the capacitor is reduced by 120 volt. So now it is V. New voltage will be V dash, that is V minus 120. When the voltage is reduced by 120 volt, the charge stored in this will be Q dash, which will be 120 microcoulomb. Okay, great. Calculate the potential V and unknown capacitance C. What will be the charge stored in the capacitor? Okay, that we will see later. Okay, let me repeat again the question and let me be clear with this, what they are saying. I took a capacitor, I connected to any battery, random battery with voltage V. I don't know how much it is. It can be 200 volt, 500 volt, 1000 volt, anything. And when I connected to this V voltage, the charge that it capacitor can store, that will be Q, which will be 360 into this, right? Now what I did, now I reduced the battery voltage. I got another battery whose battery voltage is less than the initial battery with 120 volt. If it is so less, the charge it will store will be obviously less, right? But when you are reducing the voltages, the charge reduces, keeping what that thing constant? Capacitance, right? So capacitance value doesn't change no matter what you are decreasing the voltage or decreasing the charge. Capacitance doesn't depend on charge and voltage. It is the property of a particular capacitor. So C value remains constant. So first one, what is our C value from the first one? Let me remind you the formula. Q equal to CV. This is our relation for a capacitor. So what is our capacitance in the first case? Sir, it will be C, which will be equal to Q by V. Equation number 1. Let's not make it as equation 1. Let's substitute the value here. 360 into 10 to the power minus 6 whole divided by voltage V. This is our equation 1. Now, the capacitance value still remains same. It doesn't change by changing the battery, but charge changes. So what is the new charge? Q dash. What is the new voltage? V dash. Be very careful. It's a ratio. So ratio depends when you change Q dash, V dash also changes, or V dash if you change, Q also changes. And since they both are changing, the overall value remains same. Sir, how that can be possible? So look at these values: 5 by 10, 6 by 12, 100 by 200, 500 by 1000. Is all the numerators equal? No, sir. Is all the denominators equal? No, sir. Is overall value equal? Yes. 5 by 10 is half, 6 by 12 is half. I hope this is clear. So when you change the charge or when you change the potential, the charge changes. Eventually, the capacitance remains same. So Q dash will be 120 into 10 to the power minus 6. V dash, which is the voltage, V minus 120. This is our equation number 2. That's our first one. This is our second one. Both capacitance are equal? Yes. So from 1 and 2. Let's equate them. 360 into 10 to the power minus 6 whole divided by V must be equal to 120 into 10 to the power minus 6 whole divided by V minus 120. Cancel this with this. And let's cross multiply. Before I cross multiply, let me simplify more. 0 cancels with this. And if I take 12 left hand side, it will be, okay, 36 upon V equals to 12 upon V minus 120. Let's confirm it once again. Yes, this is our equation. If I take 12 on the left hand side, it will be 12 3s are 36, 3 by V equals to 1 by V minus 120. Now it becomes easy. Let's cross multiply. 3V minus 360 equal to V. Let's take V on the left hand side and 360 on the left hand side, right hand side, equal to 360. 2V is equals to 360, and when you divide with 2, it will be 180 volts. So initially the battery voltage was 180. And what is the charge initially? 360 microcoulomb. Can we find the capacitance value? Yes. So capacitance value C will be equals to Q by V. So Q is 360 into 10 to the power minus 6, 180. 18 twos are, so 2 into 10 to the power minus 6. Or you can write it as 2 microfarad. That's the capacitance value. Let's move to the second part. What will be the charge stored in the capacitor if the voltage applied had increased by 120? If you increase the battery voltage by 120 volt. So let's do the second part over here. What is our initial voltage? So 180 volt. We have just now found it. What's the new voltage? V dash. That will be 180 plus 120. So what's the new voltage? So 200 volt. If the new voltage is 200 volt, what will be the new charge? So new charge will be equals to Q dash will be equal to C into V dash. Correct? Again, I am repeating, capacitance value doesn't change. So C will be 2 into 10 to the power minus 6. Voltage new will be 200. So the new charge will be 2 to the 400 microcoulombs. Done. So then on what our capacitance value depends? Our capacitance value depends on the dimensions, area and the separation of the plates, if it is a parallel plate, and otherwise other dimensions depending on the nature of capacitor. It doesn't depend on charge and voltage. So I hope this is clear. Let's move to our next one. Two capacitors of capacitance 6 microfarad and 12 microfarad are connected in series. So let's draw a rough diagram. This is our 6 microfarad and the next one is 12 microfarad are connected in series with a battery. Let's draw a rough battery diagram here. The voltage across 6 microfarad is 2 volt. Compute the total battery voltage. Okay. So the two capacitors of capacitance 6 microfarad and 12 microfarad are connected in series with a battery. The voltage across the 6 microfarad capacitor is 2 volt. Compute the total battery voltage. Okay, great. So here if it is voltage V, okay, the charge which is coming out of this battery voltage, let's call it as Q. And if this is the Q, the charge across this will be same as the charge across this. Sir, why? Because they are in series. So for a series combination, charge doesn't change. Charge remains same. So whatever charge is flowing or charge is going accumulating across the plates of the first capacitor, the same charge is accumulated across the second capacitor if they are in series. Let's calculate the charge for the first capacitor. So Q is equals to CV. So what's the capacitance value? So 6 into 10 to the power minus 6. What's the voltage value? So 2 volt just now given in the question. So 12 microcoulombs is our charge in the across the first capacitor. The same charge should be across the second capacitor. So if the same charge is there across the second capacitor, then voltage across the second capacitor will be equals to charge upon the second capacitance. Correct? So what's the charge? So charge here is 12 into 10 to the power minus 6. And what's the capacitance value? 12 micro. Wait, I did what? Yeah, 12 microfarad, no? So minus 6. So what is V2? 1 volt. If V2 is 1 volt and V1 is 2 volt, then what should be the battery voltage? The battery voltage should be 3 volts. Let's move to the next one. Great. Question number 11 says, three capacitors of equal capacitance when connected on series. So let's take it here, 1, 2, 3. Now, since they have not given, let's call it as C, C, C. Sir, why you took it as C, 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 not C1, C2, C3? Equal capacitance as per the question. So, 3 of equal capacitance are connected in series and their net capacitance is C1. Okay. So, C equivalent in this case will be C1. When connected in parallel, let me write here parallel. Let's draw it to make it much more simple. And here C, C, C. The net capacitance is C2. What is the value of C1 is to C2? Clear? So first of all, if this is C, 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 then to find C equivalent, what you will do? In series, let me remind you once again, in series, it's opposite of resistors in, okay, series. So that is in case of resistors in parallel, which is 1 by C equivalent, that will be equal to 1 by C1 plus 1 by C2 plus 1 by C3. And this will give you 1 by C plus 1 by C plus 1 by C, 3 by C. 1 apple plus 1 apple plus 1 apple. C equivalent in series is C1. So C1 will be equal to C by 3. Equation number 1. In case of parallel, C equivalent is equals to C1 plus C2 plus C3. So C2 is the C equivalent in case of parallel and that will be equal to 3C. Equation number 2. What is the ratio of C1 is to C2? So let's divide C1 divided by C2 as per the question. C by 3 divided by 3C. 1 by 9. So C1 is to C2 is nothing but 1 is to 9. That's your ratio.
Watch the complete playlist on the app Pions. Download the app now.